Good day, everyone. I welcome you to another episode of Organic Chemistry. And in this particular video, we'll be dealing with aldehyde, alkanone, and ether. I repeat, aldehyde, alkanone, and ether. The first thing that will come to our mind is what is an aldehyde? Please take note. An aldehyde is also known as alkanal. So you can either call them aldehyde or you call them alkanal. Why? Alkanone is also known as what? Ketone. Ether remains the same. It is called ether. Then the next thing that we should be looking at is what is their functional group. The functional group for an aldehyde is R, C, O, and here is H. Please, this one is for aldehyde, which is also known as alkanal. Then for a ketone is R, C, double bond O, and here is what is R. So this is what we call ketone or alkanone. Why for the last one, ether, is R, O, what? R. Now, in our last videos or in our previous episode, I said the R here simply means the R, wherever you see R in organic chemistry, it simply means alkyl with a general formula of CnH2n plus 1. So this is an alkyl. When alkane loses one of its hydrogen, the compound that will be formed is called what? Is alkyl. So this is an aldehyde, this is a ketone, and this is ether. Please take note. An aldehyde and a ketone, they belong to a family called the carbonyl. They belong to a family called the what? The carbonyl, or you can also call them the carbonyl. Now, in our previous episode, I made mention of carbonyl simply means carbon atom double bonded to what? Oxygen. This is a carbon atom double bonded to oxygen. This is a carbon atom double bonded to what? Oxygen. Now, if you look at this one here, it's not a carbon atom double bonded to oxygen. It's carbon single bond to oxygen, then single bond to what? To carbon. So this is not a carbonyl group. This is a carbonyl group. This is as well what? A carbonyl group, because of this bond that is present in the molecule. So after looking at that, there's another thing again we call the formyl group. A carbonyl group that is bonded to hydrogen is called a formyl group. So this is a carbonyl group that is bonded to an alkyl. So you can't call that a formyl group. This is a carbonyl group that is bonded to a what? A hydrogen. You can call it what? A formyl group. So please take note. An aldehyde belongs to the group we call the what? The formyl group. While the ketone belongs to what we call the what? The carbonyl group. Carbonyl group. And the three of them belong to the group we called carbon to oxygen functional group. Carbon to oxygen functional what? Group. So the first step is it can be a carbon to oxygen functional group. So after that, you now look at it. Is it a carbon? Is it a carbon double bonded to oxygen? If this carbon double bonded to oxygen, therefore you cannot call it a what? A carbonyl. Then if it's a carbon double bonded to oxygen, single bonded to hydrogen, this is now called a what? A formyl. So please take note. And an aldehyde or an alkanal is a very good example of a formyl group. Ketone and aldehyde is a very good example of carbonyl group. While ether, ketone, and aldehyde, they are good example of carbon to oxygen what? Group, because there's a carbon bond, singly or double bonded to what? To oxygen. So when you have a direct bond between carbon to oxygen, you refer to them as what? As carbon to oxygen functional group. So let me just quickly go to the IUPAC nomenclature of aldehyde, of ketone, and then of ether. If you have a compound like this, like what I said, this is the functional group, which can be written as RCHO for the first one. The second one can be written as, which is ketone, RCO, and here is R. While the last one can be written as ROR. Please take note. This R here can be the same and can also be different. So if here is R prime, here is R prime, it means that the first arrow is not the same thing with the second R. So let me explain this one first. So the first one we have, let's say the first member of the alkyl group is methyl. Here is hydrogen, here is hydrogen, here is hydrogen, which is CH3, CHO. So CO, and here's what? H. How many carbon? First member, but how many carbon atoms do you see here? We have 2 carbon atoms. Then 2 carbon atoms is now referred to as what? Ethanol. Assuming you are looking for methanol, will now be HCO, and here's what? H. So 1 carbon atom is now what? Methanol. Then if you are looking for 3 carbon atoms, 1, 2, 3. Here is hydrogen, here is hydrogen, here is hydrogen, a hydrogen, hydrogen, bonded to oxygen, bonded to what? Hydrogen. How many carbon atoms do you see here? Is 3. And 3 is called what? Propanal. Remember, I said 1 simply means met, 2 is earth, 3 is prop, 4 is boot. Let me stop at 5. 5 is what? Pent. So if you are looking for a 5-member aldehyde, is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here is oxygen, and here is what? Hydrogen. Please, this is a double bond. Now, as long as a 5-member, how many alkyl groups is attached to it? 1, 2, 3, 4. 4. 4 is what? Is butyl. Even though you are attaching 4 alkyl group to it, doesn't make it butanol. But if you count all the carbon atoms, realize that you have 5 carbon atoms because of the functional group. The functional group there is COH. So if you add the functional group to it, it will become what? Pentanal. So butanol is a wrong name. And assuming there's another group that is attached to it, let's say a chloro group, which is a halo group, a chlorine is here. If you want to start naming this compound, you have to start with the major functional group. I gave you the order of priority in our second episode, so you can go to the second episode and watch it. So if you want to start naming it, it's wrong for you to start 1, 2. It is best to start with the major functional group. And what is the major functional group in this structure? Is the aldehyde. So here will be my carbon 1, here will be my carbon 2, carbon 3, 4, and carbon what? 5. Position 4 is chlorine. So you write 4 chloro, then which is that thing again? 4 chloro, that's all, pentanal. So it will be 4 chloro what? Pentanal. That's how you name anything related to the what? To the aldehyde. But for that of ketone is quite different from the one of aldehyde. Like in our last discussion, I said for ketone we have RCO R. The 2 R can be the same and the 2 R might be different. So in a situation where we have, let's say, CH3 bonded to CH3. Now this R here is methyl, this R here is methyl. But if you have C2H5 bonded to CO bonded to CH3. Now these 2 R, they are not the same. This one is ethyl, this one is methyl. But this one here, they are the same. So if you have same ethyl, it's called RC double bond O, and here we go R. But if it is different, it will be RCO, and here's what? R prime. So this R prime indicate that these 2 R, they are not the same. These 2 alkyl group here, they are not the same. So but assuming here is this prime is removed, that's to tell you that the 2 R there, they are what? They are the same. So in this case, how many carbon atoms do you have here? 1, 2, 3. Let me elaborate this structure so that you understand better. So we have a carbon atom here, bonded to 3 hydrogen, 1, 2, 3. Another carbon atom bonded to oxygen, carbon atom, hydrogen, hydrogen, hydrogen. Then we have another 2 carbon atom here, bonded to 5 hydrogen, 1, 2, 3, 4, and here is 5. Bonded to a carbon atom, bonded to oxygen, a carbon atom, how many hydrogen? 3 hydrogen. Now, if you look at these 2 structures closely, the first thing that will come to your mind is, which of the carbon atom is closer to this functional group? Is it the one at the right hand side or the left hand side? You know that we have 1 carbon atom here and 1 carbon atom here. So you can actually count from anywhere. The name of this structure is called propanone. Propanone, 3 carbon atom, alkanone, ketone, propanone. This one now, how many carbon atoms do you have here? Is 4. So 4 is now what? Butanone. And if you must count, you are going to count from 1, 2, 3, 4, because the functional group here is closer to this carbon atom than the other one. So if we have a 5 carbon atom here, and the double bond is here, in this case, this side is propyl and this side is methyl. So what you do is that this side is closer to it, so you count 1, 2, 3, 4, 5. Your name will now be penta position 2, penta 2 or penta 2 on. So that would not be the higher pack nomenclature. Now you are wondering, sir, why is it that you didn't write buta 2 on here? If I should place it here to be buta 2, or if I should place it here to also be what? Buta 2, or, because then you start counting from this side. What I mean by that is that if hydrogen is here and here is hydrogen, and I place this one here with oxygen, you realize that this functional group is closer to this side and it's still in position 2. So we can only have an isomeric structure when you get to pent. So this one will now be penta 2 on, or if I should move this functional group to this place now, you realize that here will be 1, 2, 3, 1, 2, 3. So it will be what? Pentan 3 what? On. So that would be the name of the structure you are seeing here. So please, for an aldehyde, like what I said, is a formyl group, and for a ketone, the functional group is RCOR or RCOR prime. And these two R here can be the same and might as well be what? Be different. That's something very, very important you should know. What about for ether? There are two kinds of ether. We have a simple ether. We have a simple ether, and we have a what? A mixed ether. Like what I said earlier, the formula for ether is functional group is ROR. It can be prime. So if the two alkyl group they are the same, it's called a simple ether. But if the two alkyl group they are different, it is called a what? A mixed ether. So for this structure you are seeing here, this is a mixed ether. But for this structure you are seeing here, this is a what? A simple ether. Let me give you something real quick. Let's say CH3. I won't be drawing the full structure. CH3. And we have C2H5O CH3. Now, this is a methyl group. This is a methyl group. Methyl. And this one is what? Methyl. This one is ethyl. C2 two carbon atom. And this one is that's one carbon atom is what? Methyl. So if you look at this so well, methyl is called a simple ether because it is the same. But ethyl is a mixed ether because the two alkyl group what? They differs. So if you want to name the structure now, this one is called methoxy methane. Methoxy, then you go to the other part, methane. Or you have two methyl here. You can call it dimethyl what? Ether. Why this one here? One carbon atom, two carbon atom. Where will I start counting from? Please count from the side that is close to this functional group, which is one carbon atom. And this one carbon atom is what? Methoxy. Methoxy what? Two carbon atom, ethane. Methoxy, ethane. Or you can't give it a name as dimethyl ether because the two they are not the same. But assuming you have a CH3, sorry, a C2H5O C2H5. This one will now be what? Ethyl. It will be ethyl ether or ethoxy what? Ethane. Then what about if you have something like C2H5 bonded to oxygen bonded to C3H7? Now, which side are we going to count from? Is it from the two carbon atom or from the three carbon atom? I said follow the side that is closer to the functional group, which is what? The two carbon atom. Two carbon atom is ethyl, and the three carbon atom here is what? Is propyl. So what you do here is very, very simple. You just want to call this ethoxy because two carbon atom is closer. Ethoxy what? Propane. So this is something you should know about aldehyde, alkanone, and what? And ketone. Like what I said earlier, an aldehyde, they belong to the group called the formyl, but an aldehyde and ketone, they belong to the group called the carbonyl, and the aldehyde, ketone, and ether, they belong to the group called the carbon to oxygen functional group. So before we end this video, I'm going to give you a question real quick. If you have a structure like this, here is hydrogen, here is hydrogen, here is hydrogen, bonded to carbon, bonded to oxygen here. Carbon, hydrogen, hydrogen, carbon, hydrogen, hydrogen, hydrogen. Please, what is the name of the functional group? Which functional group does it belong to? Is it an aldehyde? Is it a ketone? Or is an ether? Please look at the structure very well and then answer it. Remember, if the two alkyl group of the molecule like this one now, if the two alkyl group is the same in an ether, it is called a simple ether. But if it is not, we refer to them as what? As mixed ether. Please feel free to drop the answer in the comment section, and any part of the video you find very confusing, please ask your question in the comment section. I will be there waiting for you. Goodbye. I hope to see you in the next episode.